Thanks, Murat. Appreciate the introduction. Let me share my desktop.
Yes, please.
Please let me know if it's showing up.
It does show up. Yep.
Okay, awesome. Let's get started. Um, Hello and everyone. Thanks for joining this webinar. As Murat introduced, I'll be talking through the generative AI in enterprises, and especially in this case, I will be discussing about the solutions that we jointly worked with the Google, that's AlloyDB Omni, and how do you integrate with the different LLMs to unlock the value in the enterprise. As part of this, the key topics we'll be discussing as part of this webinar. One is provide a high-level differences between what is AI and generative AI, and how is the generative AI market landscape is expanding. And when you are thinking about building the generative AI in your enterprise, what are the key pillars of generative AI you got to think about, and how do you embark on this journey? And in that journey, think about prompt techniques and the engineering aspects. And the next important aspect is the RAG, which we'll be discussing, right? So the design aspects of RAG. And as part of that, we want to introduce the AlloyDB Omni solution. And, if time permits, a demo and then and question and answers. So just before we get started, I wanted to ask, why do you know why the generative AI is catching more traction than the AI in the past, right? So, if you ask that question, right, maybe let's see if I wanted to move this slide. Okay. So in the past, the typical AI lifecycle consists of you having the large amount of data which is being stored in different data repositories. This could be Amazon S3 or any of your data lakes and everything, right? So you pull the data and go through the data preparation exercise. You cleanse the data, carry out all the feature engineering, pruning and everything. Then, this is the part of the data engineer job. Then we'll pass it on to the data scientist who carry out on building, training the model. And then, this is a rigorous exercise, right? This will be, and then going into the validate the model to ensure that it meets my accuracy, safety rules, and all that thing. Then once it passes, then get into deployment mode. So, and then the typical, the monitoring model, right? So in that scenario, okay, let's see. The AI benefits will kick in after the rigorous months of efforts that happens in the typical AI model lifecycle. When you compare this into the generative AI model lifecycle, so as the name, it's a generative AI, right? So you have the model, which is generative pre-trained transformer. So that means it is a pre-trained model that exists. You as an enterprise, if you're looking at you got to identify what am I building? Am I building a chatbot? Am I building a summarization? Am I building a question and answering, reasoning? Think about the different LLMs. I mean, the different use case. From there, you identify an LLM which serves your purpose. And there is a LLM leaderboards which will tell you, for this model is good for math multiplication. This is good for reasoning. This is good for in terms of the number of tokens, the cost per token. So there is a few parameters you got to identify which suits your need. Then you go customize it. It involves multiple steps along the way, which is from a prompt engineering, RAG, and fine tuning. We will talk about that, right? Then you go deploy the model, and the as usual process about monitoring the model, so that if there is any model drift, deviation from the accuracy or the recall, so you go and identify that, right? So the generative AI benefits will kick in with compared to AI benefits, where you have months of effort. Here, it's a few days of effort. And one of the Datadog report, which recent survey report said, some companies have brought up this Gen AI, not just the POC purpose, even to deploying into the production. It's in within a week period of time. So you can see that how the business are seeing the benefits of using the generative AI within a weeks of effort from few select again, you don't need the large detailed, I mean, very sophisticated data scientists and data engineers with some good knowledge about, the model and deploying the model, you can able to achieve the business outcomes. So that's the difference, right? Now let's see from a high level, from a, the market landscape perspective, right? So for a 2024, the data center spend for, overall that includes infrastructure, software and everything is 5 trillion. And out of that 1 trillion is spent on the software, right? The another report which said like, from the, again, from the Gartner, the year 2024, 171 billion will be the market opportunity for the generative AI. So that means 1 trillion out of that is 17% of that will be on the generative AI software. I mean, AI and generative AI. And then by year 2027, this number is going to increase it to 297 billion. So you can see that a significant, the upside in terms of the people investing in the generative AI, the software. And the last column, what you see here is one of the from Anderson Horowitz, like they are the investment firm. The average spend for an enterprise has gone significantly higher from year 2023 to 2024, from a 7 million per an average enterprise going up to 18 million. So that means a 2.5x increase in the generative AI projects. So that shows like the immense opportunity that exists for across the generative AI and generative AI. So when you think about generative AI, the key pillars, that one has to factor in is the fundamentally boils down to five key aspects. One is what is the enterprise use cases that you're approaching, and what is the business outcome you're kind of looking at to accomplish your goal, and how does my generative AI stack will look like that includes both from the hardware and the software point of it. And the third important element is the security and regulatory compliance. So we want to make sure all the investment and effort put in is seeing these models, seeing the light of the day. Otherwise, because of security or regulatory, we don't want these models to be withdrawn. I mean, all the effort has to be withdrawn, and you go back to the drawing board again, start working them, right? Recently, we have seen McDonald's have to pull back all their AI implementation on this, what do you call, like the drive-through rest thing where they get to pull back on the 100 locations, they pulled back. So these are some of the things that you got to make sure when you're going and deploying the model, it kind of suits the business purpose that what they are envisioned for, right? The fourth aspect, it's somehow tied to the first aspect, but it is all the more important to highlight as a separate category is the FinOps, that is the financial operations for my generative AI. What is my cost of developing my the AI project? What is the cost of me serving that the model? I mean, serving that right, like as the user adoption. Then the third one is the cost of scaling. Like you started off building a very good chatbot or a conversational AI assistant, but first week you will see some let's say 100 users. In a month time, this will be 1 million users. So how do you think about scaling this economically? That's absolutely important so that the returns that you are getting on deploying this model, it has to match with the investment that you are doing for scaling this model. Then for the last aspect is the new trends and how do you keep up with the up to date? Because there is so much changes happening both on the infrastructure, in the application on the software side. So to make sure that the enterprises are keeping up to date, so that the competition is coming out with implement something very breakthrough approach, thereby all your efforts should not be undermined, right? So that's the key fundamental five aspects. So let's dig into one at a time. Let's pick from the use cases perspective. The use cases can be split into two aspects. One is from an industry vertical, right? Another is from a horizontal, enterprise functions. From an industry vertical perspective, like you can, I mean, I just only listed three. There will be umpteen other use cases across different verticals. So the retail is one of the popular use case. Let's say, we're highly adopting the generative AI. Let's say, there is a 70% of the US population do an online shopping. and an average spend is around roughly around $3,500, right? An average spend about, right? So now when you translate this in close to a 900 billion or close to a trillion itself, it's spent on the online shopping. So most of the retailers are working. How do I make sure that dollar spent on this online shopping that's happening is diverted towards my e-commerce website or a portal, right? So that's very significant. And there is a significant, and one of the NVIDIA research reports says like, there is a adopting the retail industry, consumer and retail industry will see an upside about almost like a 300 to 400 billion dollars by using the generative AI technology across the board, from a improving the shopping experience, virtual shopping assistant, and converting this, the things that is being the shopping cart into checkouts, right? So all these things will see a significant upside on this. When it comes to the second aspect, which is a banking and financial sector, here the typical use case is one is on the risk management to make sure the banking and everything is completely secure, right? And the second one is a fraud identification. This is more importantly, and not only identification, detection, and mitigation. So, and where not only for dedicated to the transaction, as well as like, for the payment transfers and everything that is happening, and the portfolio allocation, right? Like, so that you're kind of spreading out your things in an optimal way, where you will find a better returns on your investment on the portfolios that you're doing. So one of the McKinsey reports says that the banking and FSI has seen almost like a 30 to 40% in reduction in terms of in their operational cost adopting the generative AI. So what does it mean is like, typically FSI or banking and FSI, they spend in, the IT spend is directly proportional to the revenue they're generating. So imagine that using this technology, you're kind of bringing down that kind of cost of investment that's happening. That's a significant upside on the banking industry. The content and media is pretty much same, like, based on the embeddings that is generated, it'll be a highly curated content will be, shown to the users, so that way they'll get a better traction with the higher adoption. So horizontal functions, the customer support is one of the low hanging fruit, where people are building a conversational chatbots to improve the understanding the customer needs and improving that conversational chatbots to provide very superior customer experience for the users. And again, this is another McKinsey report which has said like a customer using the generative AI technology, the average resolution time per hour, they're able to see around 14 to 20% of reduction. And that will translate into almost like a 40%, 35 to 40% of operational cost for any contact centers, right? That's a significant benefit for a customer support. And when it comes to marketing, the marketing, it's not just about, creating a very, beautiful images, content and everything, like, but using a few couple of lines of prompts, you can create a very good marketing campaign, right? So that's another risk. So one of the customer, especially in the banking, they using the generative AI, they're able to provide a 20 million of hyper personalized offerings to their customer and existing customer and a prospective customer, to acquire the customers and also retain the customer. So use within the 3 months of launching that product, they're able to provide that kind of a 20 million, right? So HR and finance, it's about like, all the billing and everything, real-time invoicing so that you can expedite the billing cycle. So across the board, like you see that like, there is a significant benefits both from the verticals as well as on the horizontal function. And this is a report from a survey from the ITDM, right? IT decision makers. So what is their objectives of implementing this generative AI in their enterprise? So there's a 90% of the people, like IT executives said, like, I'm investing in this, I'm looking at reducing the cost. 27% said, I'm going to increase the revenue in my core business. And 23 and 30% said they're looking at expanding the revenue opportunities beyond going from, reducing the cost to, right, new lines of revenue, increase the value of that offerings. So that's significant uptake on this. Now, the next aspect of this is like, so what does once these are the benefits, how do you think about, what is my generative AI, the stack look like? This can be broken down, classified into three aspects. One is from an infrastructure. So this is that infrastructure which is more for not only for designing, developing, and also deployment. So, and this could be a cloud infrastructure if the customers or enterprises are more existing, all the databases, their data, everything sitting on the particular cloud, then the gravity pulls into that direction. But if the enterprises is more about, right, like, there's a regulated industry, they cannot, put this proprietary data onto the cloud. I mean, especially the data that you feed to the LLM for either for a prompt or other RAG purpose, they will go for an on-premise or in a hybrid model. And even if the enterprises, their USP is more about a differentiation, intellectual property and those things, they completely staying in the on-premise. So the deployment when it comes to infrastructure, the chance of that deployment will completely depend upon what the enterprise, the nature of the, right, like what they have the, whether from a regulated industry or, based on that will define. Then the next aspect is onto the model, right? So the model here, what it will happen here is like when you are in a cloud infrastructure, right, like you have existing already leveraging some cloud. So more often than not, you end up adopting a particular the model from that particular cloud. For example, Google Vertex AI, it'll has, you get more, if you have your existing data and everything sitting in the Google Cloud, there's more often than not, you'll pick up a Google Vertex AI for utilizing the model for that, right? And the same thing applies for the Azure and the AWS and every other same aspect, right? So, and if you are more neutral, like, in this case, like, for example, on-premise or a hybrid where I am, I have defined my infrastructure. I'm looking at now what is my best model that I wanted to go pick. So then you go into the second tier where you will think about a model provider. Here, the model provider, you can go into Google Model Garden, NVIDIA has the equivalent, or you can go into the Hugging Face where these are very optimized models set up in the Hugging Face. Then you pick up that, right? And then from there, you go and find out for this model, if I'm going deploying onto, right? So which infrastructure gives me a lowest cost? So that becomes your deciding factor. Then the orchestration frameworks, like, all these things, LangChain, Llama Index, all these things will be very extremely helpful for not only for the prompt chaining and building the prompt templates as well as the RAG models. So both LangChain and Llama Index as the equal, but LangChain has much more benefits compared to Llama Index and more seamlessly integrated, but Llama Index also picking up very quietly. And the next aspect is on the vector databases, right? So this is another core part of it, like where there is a lot of application already built and leveraged using in a traditional applications already using these databases. Now you're kind of converting that applications into a Gen AI enabled applications. So that is where this vector database comes into the picture. We will delve into much more detail into how, what is vector database and everything in a little later. And then monitoring and observability, right? Like here, you wanted to make sure, like once you go deploy this model, like, how is my performance is looking like? What is the, right? Like, is there a model drift or there is any deviation from this? So all this is very important. Like there are tools that is available. So when you're looking at a full stack, all these things will be taken care by default from these full stack offerings. But if you are going and individually picking it, this is how you'll typically approach. So then what is my applications, right? Like, I'm looking at a content generation, summarization, classification, so all these aspects will define, this is the application tier that you're kind of looking at once you have this, the infrastructure tier and the middle tier is being figured out. The security and governance will be added to make sure that your model is confined to all the security requirements, and the application is confined to that, and also the governance, which is whether you from a HIPAA compliance or GDPR or whatever the requirements that is needs to be fulfilled, so that this your generative AI will be taken care. So the models can be classified into three different categories. This can be, one is from an open source model or a commercial model, right? Like that's one way of approaching it. The other aspect is whether you are kind of looking at this from a what do you call, like a from the size of the model, right? Because you are looking to make sure you're optimizing the cost. I don't want to go and pick up a big, large model because I don't want to spend, right? Like then think about a very a entry level, low end model. I mean, entry level model, which is like from a Microsoft. What's that? Okay. Okay, sorry. From a Microsoft E3, Google has a Gemma, Llama 3 has a 8 billion parameter. So this is more suited for if you're looking at building a specific use case. For example, you're more focused on marketing, right? Like, I'm highly curated content I wanted to build for marketing, then this is perfectly suitable. Then when it comes to much in the somewhere in the middle, right? Like, for example, Bloomberg has built a FinGPT model, very, I mean, customized and fine-tuned more for fintech world. So this is something where you have, and even there is something similar approaches is being done on the healthcare side, where, very domain-specific model, right? So you can pick up the model from the Llama, Mistral, even Google Gemma has a equivalent, it's a 7 billion, I believe so. Yeah, they have a 7 million. Maybe it will not fall into this category. So these you pick up this model, and this is you go and optimize for the specific requirement. Then the third category falls into the sophisticated use case, which is a multi-model LLM. Like means the first two are meant for a text, right? Like you are kind of generating the text out of it and all. So when you think about multimodal, you are kind of looking at these models are being trained on not only on the text, but it is trained on the videos, images, speech, and other things, right? So the multimodal LLMs comes into that picture where the Google Gemini Pro, the recent OpenAI is a ChatGPT 4.0, all these meant, falls into this category of the multimodal LLMs. Now let's see. So as I said, like these LLMs or multimodal LLMs have been trained, typical LLMs are trained on text and data, but multimodals have been trained on text, image, and videos. And with hours or, several hours of GPUs consumption, these are fine-tuned, pre-trained, and you'll get a foundation model. The first aspect of that is like, so one is the prompt engineering, where you define a prompt templates and use the LLM, the foundation model LLMs to accomplish your specific requirement, right? A very generic, whatever the use case that you're. We'll talk about the whatever the use cases in the next subsequent slides. This is the foundation. I mean, the first element of it. So once you accomplish that goal, and the next step of your maturity or advancing to is specific problems, right? Specific problems that you wanted to think about. How do you bring the enterprise data from your existing databases or data? I mean, the Word documents, PDFs, or URLs, external, internal URLs, all that thing. So integrate the external data set to the LLMs and build a RAG, retrieval augmented generation. We'll go again. This also will delve into that, a lot more detail into this. And here it is addressed for a specific domain-specific problems pertaining to whether it is for a Target, Walmart, or healthcare. So depending upon which use cases the enterprises are looking at, you can go integrate that aspect. The third aspect is on the fine tuning. So the RAG will help to solve certain, by integrating the domain specific data and this, but still there is an opportunity still exists to go pick up that foundation model and fine tune to really highly curated data set using the fine-tuning techniques. Again, we'll delve into this detail, but as you see here, this is how you can approach enhancing the model accuracy, model relevance, I mean the response accuracy, response relevancy, and more fine-tuned to your domain-specific requirement using these three fundamental approaches. So the prompt technique, we can put this into two categories, right? Prompt technique can be said as a structure of how do you define a blueprint for the prompt, which is defines the role, the outcome that you wanted to accomplish, the context that you're providing, intent, all right, like, and the constraint. So for example, me as a journalist want to write a journal. My goal is the context is around making a climate change, context around climate change. My goal is to create that awareness, and I want to come out with that article limited to 500 words, right? So this is how I'll go define my prompt technique, where I'm going to define in the prompt template, act as a journalist, write a journal with this context around climate change. Goal is to make this, right? So then the next step is all the models provide these model parameters, which is one is the temperature, which defines zero is says that, like, you get very highly stable data, very rigid, I mean very existing data set. I mean, this content will be generated based on the very conformed, very trained model. But if you pull drag that bar from to 0 to 1, then this model becomes a little more creative. Like, means it'll start imagining the things that you would have not seen so far, right? Which is good and bad, right? Like, that is where the hallucination will kick in. Then the top K number, right? Like, which is when you are kind of the top K is number about predicting the next the word, next sequence, and everything. So out of the text, it predicts 10 possibilities, which one you want to be, like, whether you wanted top two, top three. So this defines that. Then the probability top P will define the probability of that smallest data set that you are picking up. The other aspect is on the prompt engineering, where you're kind of picking up, like, now you define this prompt template, I mean, the prompt techniques, but you want to think that, it has to be highly much more improved upon. That is where the prompt engineering comes in, where you curate or provide more tools so that the response from this LLM will be more relevant, more accurate. And some of the techniques that will be used is the zero shot, few shot learning, where this is a more about in context learning. You provide an example so that I mean, I'll talk through about the next subsequent slide, where you provide an example to make sure that LLM understands the example and learn from it, and then provide a much more accurate response. The next step is the reasoning. You are improving the reasoning of the LLM model so that you get much more, the responsiveness increases even further. One is the chain of thought, tree of thought. You are making the model to think a step by step so that the response will be much more highly accurate. Then the last one is on meta prompting. Here you almost say that, like, this is the desired outcome I wanted from my model, I mean from the prompt output. You create a prompt for me, right? So that is where the meta prompting comes into the picture. So now what am I going to accomplish from the prompt engineering, right? So you will be feeding this prompt request of defining the prompt templates from a user interface, any of the playgrounds, whether it is on Google, getting into the Google Vertex AI, Azure OpenAI, right? Or Amazon Bedrock, or any of those things, or using an SDK, software development, like, if you are a developer using any of the Python, Node.js, and everything, or just using it as an APIs, right? Like I call that, all these model providers will provide that APIs. You can call that particular API and get the, right? So here from this, you define a task. From the LLMs, that's the typical things would be is one is a sentiment analysis, like when a given text, whether my customer is providing a positive feedback or a negative feedback, and you have a one page of document. I don't have a time to read entire content, right? Like, get me a quick 4 bullet points of summarization for me. That's really helpful. So instead of spending entire, the 2 pages information, you can quickly grasp the essence of that in 4 bullet points. Then comes to the chart part, right? Like, I think this is everybody understand there is nothing much. And the code generation, right? Like, so depending upon, right, like, if you're gay, you're a backend developer, but you wanted to come out with a front end HTML, CSS, some of these things. So if you want to quickly build that UI component to it, that is where the code generation comes into very handy, right? And in the multi-model LLMs, right here, you're going to, you extend whatever you can do it on the LLM, but also you can accomplish, generating the images. Like Google has an image gen. Diffusion model is not the multi-model, but so okay, I see that. Diffusion model is multimodal, but you can generate the images and you can generate the captions from the images using generate text. And the speech, right? Like the transcribe that you can do it, and the same thing from speech to text and text to speech. It's vice versa. You can definitely do that with the multimodal. So here's the one example. Let's say, NVIDIA GPUs, everybody using left, right, and center, so there is no questions about it. But it's a very simple example to illustrate how a few short example can be used to classify given NVIDIA GPU is a basic or an advanced. So I provided a prompt template. Example one, I said, okay, TensorFlow 32, Tensor TF32 Tensor core. If it is less than given 989 teraflops, classify that GPU as a basic or an advanced. I'm saying that answer is basic. Next, the GPU has a 34 TensorFlow 32 tensor cores. It's greater than this 1979. Classify that as an advanced. Now, these are my two examples. Then I've asked the question, right? I have a new GPU. Let's imagine that there come, let's say an AMD come up with, Intel comes up with, they've already came up with, right? So how do you classify that, right? Like, now using that, let's say this GPU is at 800 teraflops. How do you classify it? So you see the answer, like this is a basic, right? Because I have defined the template, it automatically classify. Then when it comes to example four, like, I'm providing 2021, right? So then it calls it an advance. So this is how you can make the model to learn to suit to your needs. Even though these models don't know what the teraflops are and all that stuff, but by providing that few shump example, you made that model intelligent to suit your needs. Next is a chain of thought, right? Like, here I've used my own example, like to illustrate the point that I will. So let's say the PostgreSQL is, one of the, popular, no, I mean, popular database used in the enterprises. So let's imagine that, I didn't assign any units, but just for this illustration purpose, like, the performance, it does some, let's say 200. This could be 200 transactions, right? Like, but and the latency is 400 millisecond, right? So let's define that. I mean, this is my parameter that I defined for a product one. And AlloyDB Omni takes that performance by 400, latency cuts down by 200. Then what we working with the Google, we change that, increase that performance into 400 into 800, latency into 100. So this is my parameters that I fed to the model. Now I'm asking, like, user message, this is my requirement. You help the users who are logging into this website or a portal or a chatbot to say, okay, now based on this, how much is the benefit of what percentage of things with Lenovo and PAP's solution with AlloyDB is superior compared to PostgreSQL. So this is the simple the prompt I developed and came up with. The answer is, right, you see that 4 times or the higher performance than calculated by dividing the performance AlloyDB Omni with this 800 by. So though the model doesn't know all these parameters, defining, I mean, this what this LRDB Omni is, like the Flaps is, the Lenovo, and what is the performance. And so by providing this into kind of a chain of thought, you made this LLM to think step by step to arrive at the conclusion. So this, I used it in an example. I think you can perfectly use it for various other. So here I'm coming this extending it to one more use case where I have an electric bike, just to make sure that how am I doing on the time? Um, I have an electric bike. Let's say you are selling electric bikes. I picked one of the electric bike from an Amazon portal. I defined, this is my JSON document for one JSON document, right? I have a V Electric is my brand, mountain bike, and it does have 1,000 watts of motor, right? And then it runs max range. It can get once it for full charge it get me a 40 to 50 miles, max speed 25. All these parameters I put these things. What is the price range, right? Now I can go build a conversational chatbot just using the prompt template to say, okay, you are going to act as an e-bike conversational assistant. So your goal is list the bike, right? Like this, if I have a 10 models, I can go pull all these things and put this into the JSON, right? Like the prompt template and define, right? And when the user comes in, ask, okay, get me what is my, the latest models in the electric bike. It'll list that. Then you can go and ask a question like, I wanted a range about, my day commute is around, 30 miles. Provide me the list of models. It'll get you the next one. Then it has to be within this particular range. Then you narrow down. So it kind of, you can build this kind of a conversational chatbot using the listing the bikes, matching to the user's price, range, charging time. And then once you do that, the next step would be add to order, right? So based on it matches everything, then you can go add to the order, provide that option automatically to add to the order like as part of the prompt template. Then summarize the order to confirm, prompt that user. Okay, I'm going to confirm that, right? Are you good with that? Then, like for example, they say, okay, the user has changed his mind. Now he wants to change it with a lower price because he felt that it's too much he is spending for a buy. Then you can go and change and come back and go and change. So change that item, provide that, then again you summarize, right? Provide a customer added the new list and right, modified this. You can go and summarize this, confirm this order with the customer. And finally, once everything confirmed, the finish the order, provide a response to the order that your order is sent to the delivery. So here, this way, using just a setup, a prompt template, entire workflow can be automated for a conversational chatbot. So this is what I was referring to on my initial slide about retail, right? So here, there is no particular a customer support agent sitting on, to provide this. It's completely can be automated using set of, prompt template. LangChain provides something called LCL, LangChain Expression Language. That's very handy to accomplish this. Okay, so let's get into the multimodal aspect. Let's imagine you're in the airport. By the way, I picked up this from the Google multimodal the course itself. So here you're in the airport. Now I say, okay, I'm going to take picture of it and pass it to my model and say, okay, pass me the time for different departure times and the cities from this, right? So it will get you all the different departure times. But if you were to say, what is the distribution of the flights, going into different geographies, Europe, Asia, North America from this particular airport, it'll do that. It'll accomplish, right? So this way, it'll let you to take the more, I mean, the images and the pictures of certain things, then you can go and ask in very interactive questions and get an answer. The same thing for a retailer, maybe, where I have let's say, you go to walk Target or a Walmart, right? Where the some of the, let's say, you pick up some 4 apples, 6 oranges, right? And these apples, you don't need to go and punch in like one apple into each price is, let's say, 50 cents. And I picked up 8 apples, that is a $4. And so if you provide just the images of apples, oranges in a picture and the on the right hand side, what is the price per apple and this. The Google Gemini has that intelligence to tell, okay, this picture has this many things, and this is the price, and this will be the total price you'll be end up paying for it. So this way you can see that right in the checkout when you go into point of sales, like this kind of a checkout where you don't need to have punch in all these numbers to arrive at that, because there is a multi-model is built and enabled to accomplish your goal. Um, I mean, going this into further a few more examples, like, I tried this with a Gemini and also worked with a ChatGPT 4.0. It worked perfectly fine. But by the way, the previous example didn't work for the ChatGPT 4.0. Like, it was not able to figure out what's happening in that image. But here, this worked in both the models where I fed the things that we tested on the AlloyDB, the graph, and this one to Google Gemini and ask, explain what's happening with this graph. It, with I mean, explain and also ask what is the average performance gain. So the answer, this was the response from the Gemini saying that the average performance gain of the AlloyDB Omni with this is approximately 4x, right? So looking at the graph and these numbers, it automatically arrive at what will be the average performance gain. Then for a restaurant, like, for example, DoorDash and everything, you get this food, but it doesn't tell me, like, I'm a vegetarian. I don't know, like, the food that I'm eating is sufficient enough for me to, in terms of the protein and everything. So providing this kind of the images to the Gemini model, it'll help me to get that with this food item, like, these is the what is the contents and what is the vitamins that's available from a vitamin and the protein and everything. So broccoli, patties, chickpeas, and so everything. Then when you go into the tourism, right, like, where whether it could be applicable Airbnb or the hotel and different. So you take a picture of this and say, provide very descriptive view about, the room amenities, right? Like, it gave me with it's a ocean view, clean decor, natural light, you get a comfy bed and so this way, where from the images you can start generating the required the text, so that you can, based on the particular personas that you're thinking about, you can start populating that particular information, and so that you can create rich marketing content out of these multi-models. Okay. Okay, let me quickly, I think we spent enough time on this more. So the next is the RAG, where retrieval augmented generation. Here we are talking about, like, I have a website. How do I read this document from website, book, database, API? So the next step would be is like, when I get this thing data, how do I chunk it? That means I'm slicing the data, entire PDF document. There's a 10 pages, I'm slicing it page by page, embedding, converting that this data into embedding and storing, and then indexing. Now taking this into high level picture, like, let me, oops. So I have the data sources. I'm going to chunking this, like, slicing into multiple, embedding, like translating that into vector format, indexing it, vector database, like, storing the LRDB Omni is a excellent vector database to serve this thing, and chunking, like, when you get a query from the chart bar, I mean, from a user, right? You asked a set of user prompted a question. Then from here, it's going to look into this, the embedding. From there, it'll the data, and from there, it'll know where the data is stored in particular vector, in this case, the LRDB. And that particular chunk of the data is pulled to passed from the augmented RAG, and then from there it passed on to the LLM, and the information is fed back to the chatbot. So this is how the entire RAG architecture works, from getting the directional data, integrating to this, and providing a very domain-specific response to the users. So since we talked about, like, AlloyDB, let's take a step back to see what this AlloyDB Omni is all about. So AlloyDB Omni is a database product from Google. It's a fully compatible Postgres compatible database, and it serves as a three-in-one purpose. Like, you can use it for a OLTP for capturing all the database transaction. or analytics if you wanted to carry out any real-time analytics on it, and as well as building a chart path with a built-in vector database functionality. And the second aspect is like, it's so flexible that you can go put it in a edge servers or in the data center servers or into the public cloud, right? The same data, not necessarily in the GCP, you can put it in other cloud providers as well. And it has got a automatic vacuum, what's of the major pain point in the Postgres, and memory management and all the stuff. We'll talk about this a little later. So we picked up this AlloyDB working with the Google to say, okay, now we wanted to find out, like, we know the Postgres is highly adopted in multiple enterprises. Like, if we were to use an AlloyDB in place of this, right, what's the benefits of it? So the first, when we carried out this HammerdDB TPCC benchmark, we realized AlloyDB runs 2x faster than the PostgreSQL, like 500K transactions per minute. Then you're running at almost like a 1 million. Then running with the Lenovo and the Plabs, that performance shot up to 2 million transactions. So that means 4x transactions compared to the PostgreSQL using this combination. And then what does it mean for an end user? It can serve more web and mobile requests. And this works with the seamlessly data growth that is happening into the enterprise. So the transaction is one aspect, but the response time of an application when you are pulling, doing a transaction or placing an order on the e-commerce website is highly important. And when we measure the latency from PostgreSQL, AlloyDB reduces that latency by 60%. Then the combination with AlloyDB with the Plabs and the Lenovo, it reduces by another 25%. So you can see around 85% of the latency reduction for a P50, which is like an average latency. Our goal is to make sure just not the 50% of the user, right? We want to make sure 99 users, maximum users get out of the 100 users, 99 users get a consistent low latency. Even in that scenario, comparing to the PostgreSQL, as you see here, with this combination, we are able to reduce a 64% of latency reduction, 64% of latency reduction, going somewhere, as you see here, somewhere around 55 millisecond, reducing it to 25 millisecond latency reduction. So that's one aspect. Now, typically, you have these products, the e-commerce, the retailer, right? So I sold this product, right? Like, but I wanted to see before the next item, the order comes, whether that item exists in my inventory or not. That typically, in typical scenarios, you will go fetch this from a data warehouse and pull this data, and then find out that information. But in this case, with the AlloyDB built-in columnar engine, you don't need to carry out such, right? Because a built-in columnar engine with a real-time analytics capability, you can accomplish this where AlloyDB recommends what tables to populate, what is the memory you need to accommodate, and then you populate the data moving from a row store into column store, allocating a columnar engine memory. Then with that, we're able to test with a TPCH. Google has tested this with this, moving from a row store to columnar store. They've seen a 100x performance benefit. But when we tested, we wanted to make sure there's a more stringent environment where there is an identical memory for a row and column, and also all the data set is sitting in memory, right? Like even then, moving from a row to column, we saw around 4x performance improvement. Certain queries like query 4 and query 6, we have seen around 16 to 20x performance benefit. So this is immensely helpful. Like, what are my top products been selling? Should I add a discount to my products if there is any lack of sales? This is especially, during Thanksgiving or Christmas time. You got to think about, like, how do I scale and make sure that my real-time analytics is, providing the accurate information so that I can take a real-time decisions, right? That's extremely helpful with the AlloyDB, all right, the columnar engine. The next one is AlloyDB implementation, where here Google provides a set of AI capabilities for users where you don't need to go introduce, right? Like you can go and create the ML integration and a PG vector also compatible with the PG vector. You can do it, right? And then register the model, right? Whether you're looking at a Llama 3, OpenAI, Vertex AI, you can register that particular model, and then you provide an execute function on that particular user which is registering, and then you can start fetching the embeddings from within the database itself. You don't need to switch back to your Jupyter notebooks or any of the IDEs. Within running this command onto the Google command, the Omni command prompt, you can fetch the embeddings out of that. So that's a very significant, and also serves as a kind of an endpoint using uh, the Google LLDB only within the command prompt. The next, once you store that embeddings, the next step is to identify how is my right, like what is the distance between these embeddings. So the typically, the for vector embeddings, so there is fundamentally 3 to 4 concepts where how close to particular, let's say girl and boy, the data should will close to stored together, right? Close to very nearby. But if you say a girl and let's say some other tree, then this there is a distance between these two vectors will be much more. So identifying that kind of a distance between these two is highly important. And some of the techniques used is, one is a Manhattan distance, which is like a which provides a square root the sum of the absolute values of the two vectors, the distance between the two vectors, which is the Manhattan distance. The second one is a L2 distance, which is also called as a Euclidean distance, which is a square root of some of the absolute values of the two vectors. It will provide the distance between that. And the third one is the cosine distance, which measures the angle between the two vectors. The L1 and L2 measures the distance, whereas the cosine distance provides the angle between. So if your data set has got highly dimensional, as the dimensionality of the data set increases, the cosine distance provides more accurate results than compared to L1 and L2 distances. But of course, it takes some amount of the resources on the compute side. The next, once you identify the distance between the vectors, the next one is the indexes, right? The typically, when a scalar database, regular traditional databases, you have the typical indexes will be very extremely helpful for a keyword search. But here, vector database, you need a special type of index. That's where the vector indexes comes into the picture, where it will fetch the data between the comparing the vector. Right. So in the Postgres, it provides two types of vector indexes. One is the IVF flat inverted file indexes with a flat compression, which is the vectors are organized in the form of a cluster. When the query comes in, it will identify which is the closest cluster matching to particular query. And then from that cluster identified, then it will navigate to the within that cluster, which is the closest list, right? Like, from the centroid of that query, it'll identify the nearest element and pass on to this. IVF flat is very helpful. Quickly, you can build the indexes, get the results and everything. But not necessarily the results you get will be highly accurate. That's the right. But you're looking at highly accurate results. The HNSW, which is a hierarchical navigable search world, will be extremely helpful, which is organized in the form of a graph, multi-layered graph. As you traverse from one layer to another, like the data set is a subset of the previous the layer. So this provides a highly accurate results. One drawback about more you get a highest performance, good recall with the HNSW, but the drawback is, one, it takes up significant the space. Second is creating the index takes a longer time, and the maintenance of this thing is a little more complex. So this is the pros and cons of using the different indexes within the Postgres. To address these challenges, right? Like, the Google has recently introduced something called a SCAN, which is a scalable nearest neighbors index, which is extremely helpful, like which provides a best of both worlds. In fact, the better of the HNSW itself, where it is organized. HNSW is in a graph. Here is a tree where search query it comes, it prune this the branches of the tree. So and compresses using the quantization, it will compress the data set. So thereby the index creation time will be much quicker, and the memory consumption will be almost like a 3 to 4x. So index creation time is almost like a 8x faster. The memory is reduction is around 3 to 4x reduction in the memory compared to the HNSW. And other aspect is like, the query performance is 3 to 4x faster. So that's the key benefit of the scan indexes from the Google, right? Now, the other aspect, which will help to improve the accuracy of that is one is going from a naive RAG to advanced RAG to modular RAG. So the naive RAG, what it does is like, once the data set comes, like, so the retrieval process will fetch the data from the external data set and integrate and then pass down to the LLMs, and that will augment the data and pass and generate the final result and passed on to the user. Whereas the advanced RAG takes this, as the data set comes, it does the the query expansion and the re-ranking. It's like, it's almost like an order by class if you're a SQL developer. So it does an order by class and sorts the data that is fetched, and then from there, if you have a follow-up question, right? Like, let's say Google, this is my revenue for this particular quarter, but which product line has generated my revenue out of that? Which is my top line revenue, which is growing? Which product line is contributing to significant? So if you have a follow-up query out of that, that is where the advanced RAG will be in. The modular RAG is much more scalable, like where you can define the number of ranks and rewrite ranking, retrieval, and everything. So this is so this will help to improve the accuracy of the right. Like what you're seeing is one, you using different embeddings, and the second one is the distance metrics that you will use from a Euclidean distance, cosine distance. Third one is the indexes. Then going from a basic RAG into an advanced RAG. These are the techniques that you will adopt when you are building kind of the chatbot models, right? So yeah, I mean, the use cases of RAG is one. You can build a very, domain specific chatbot. You can detect the anomalies that is happening in the transaction, like, whether this user has any transaction which doesn't match that particular thing, detect this in real time, by using the vector embeddings, and then provide, looking for a similar content. These are the use cases. And the benefits of the RAG, as you see in the picture, like, without RAG, accuracy of the model, let's say GPT-4 Turbo is 0.7. We're using the with the RAG, that accuracy jumps up to 0.835. The same with the Mixtral 0.8583, it goes up to 0.808. You can see a significant boost for a Mixtral model. And the Llama, the same thing, right? 0.6 going into 0.7. So these are the benefits of using the RAG to reduce the hallucination, increase the accuracy, and you can even cite the resources, which data, which resource, source of data that I'm pulling this from. Again, the RAG can be extended even to build a rich workflow automation. If you have a product collaterals, pull that data, create a marketing content based on persona based, whether it is a developer, a solution architect, IT decision maker, and from there build a chatbot to write, like, using that same thing. You can build a frequently asked questions and anything related to deployment for your product that can be taken care through a customer acquisition. So this will help in the customer. Then customer retention. If there is any feedback that is received from Slack, Jira, social feeds, carry out a sentiment analysis, classify them on a positive and negative, and based on the response you get, positive or negative, provide very personalized email onto the customer feedback, thanking them for a positive, and and if it's a negative, say that, okay, we identified this, we are working on this. So these are the significant benefits of how do you tap into RAG to make you are retaining the customer, so that the negative sentiments should not affect very significantly. So now putting this foundation layer, everything like in LLM foundation, like you have this Vertex AI, you can integrate, pick up the model from Vertex AI, Gemma, OpenAI, you can right from this, and then orchestrate using a LangChain or Llama index for building the prompt templates. Two, AlloyDB serves as a database layer for a vector search with a PG vector, which talked about, and a natural language asking a simple conversation to converting into SQL, and intent clarification. If you don't know what you're exactly asking, but it has got a intent clarification to make sure that it'll clarify what you're trying to accomplish. And from a security, it's got a parameter secure views. You can define from the model access an endpoint, create an embeddings within the database itself, and use the Vertex AI inferencing. Um, so this is a high level, like, putting at a LLM model. So if your goal, taking this to next step into, I want to improve the model accuracy further, improve the response time, reduce my energy consumption, reduce risk, and reduce cost. This is my LLM optimization goals. And the optimization techniques you use, one is quantization model, reduce from a floating point 32 into floating point 8 or 4, then pruning techniques to reduce the weight of the model by taking out few layers or reduce the weight of the model. Then the distillation technique, which is like a teacher and a student technique, where you will reduce that. And the low rank, LoRa is another popular thing. LoRa, QLoRa, low rank approximation, where you reduce the size of the model. I mean, and still maintain the accuracy of that, right? So, and summing up, like if you have this, right, like, so you're hosting on on-premise or cloud, what you're looking at is like, what is my infrastructure cost, then inferencing cost, the inferencing cost, prompt tokens, how much prompt is being used, and completion tokens. So that will define my inference cost. And for a RAG, like, the RAG database, right, which the type of database you're employing, and then LLM inferencing cost. Fine tuning is a one-time effort, but it requires a significant GPUs to fine tune the model. Then what is the duration of this? How many layers and how many epochs, batch size, and some of these things will define the fine tuning inferencing cost. And then finally, if you're building something from a scratch, then it's a pre-training cost, per inference cost. Everything will come from a overall building from a scratch. From the total cost of, if you are taking an end-to-end, right, like, what is my LEM performance looks like from a cost and performance, hosting cost, application integration, going back to the scalability, like, I have a, 1,000 users today, next month I have 1 million. How do I scale, right? Like, what is my operational overhead that will becomes, and the monitoring cost, so that the model will not be drifting significantly from what it is being defined. Yeah, so when you're defining about next data platform consideration, you have to think about how your data has to be moved from edge to cloud, how to have a seamless one technology ideally, so that you have transactional database and everything, analytical database, and also vector database, everything. And thinking about a robust enterprise support. When you're a customer, you got to think about, like, you don't want to enable the model, and then if there is a lack of support, that's an important aspect. Then in open source, like, it's compatible to open source, so that in the down the line, there is wanted to switch over to some different technology, it should enable it. Given all these things, we built this one platform to serve different analytical needs of the enterprise, from an infrastructure side, Lenovo edge servers with the Plaps acceleration, data centers, again, like, with the Plaps acceleration, and a Google Cloud for AlloyDB Omni, which Omni runs in both on the edge, on the on-premise, right? And the AlloyDB runs on the Google Cloud. And it's a single database to serve as a transaction store, columnar store, and a vector database for you to build from a e-commerce application to carrying out a real-time and generative chatbots. I think that's pretty much well done. Thank you very much. I'm open to any questions we got. Oh, a few questions. Okay. Are there any security solutions specifically developed for the Gen AI stacks? There's a lot of security aspects and security tools that's coming from a different tool providers. But if you are looking into what do you call like a from a picking up a end-to-end model, like, for example, Google Vertex AI, it has got all the security frameworks built into it so that the model is not hallucinating significantly, right? So all this, and it is not responding to, very inadvertently into significant at this point. So slide 8, language-based task, do you mean by text-based task? Um, I guess you're referring to the multi-modal. There is also text-based as well as language-based. So depending upon the type of model, you'll have it'll serve both the purpose. What are the trade-offs to watch out moving from a row-based to column store? So yeah, I mean, if your intention is to carry out the analytics on top of the row store, I mean, the data. So then the column store is highly prudent to go switch into that direction. But if you are carrying out only the transactions, then you should stick to the row store concept and start using it. So depending upon what the use case, you have to use appropriately. Discussions on the storage formats because they're are showing us the discussions on storage formats because they are used to store the showing us this discussion on storage formats. They are used to store the deep learning layers LLM model. GenAI ops cost. Yeah. Yes. GenAI ops cost definitely I would. Yes. Okay. I think how do you evaluate the accuracy? Yeah. Good question, Jay. So yeah, I mean, maybe I had this slide. The accuracy of the rank, there is something called a blue score and a bird score. That will tell me, how is the performance of the rank. How it is being provided. For a fine tuning, as you're kind of tuning that, you automatically shows the how is the model loss is being reduced as you increase the number of epochs and right. So the RAG, you got to do an extra step of validating, calculating the blue and bird score, but fine tuning, while you're carrying out the fine tuning, you yourself will see it. Maybe some other time I can show this live at some stage. Um, okay. For senior executives who want to be able to plan to sell these projects to the C-suite, but won't be able managing them hands-on. How would you suggest get up to the speed on the foundational tools and capabilities described? Okay. For a senior execs, to sell these projects to the C-suite. Yeah, so I think that's where I had a slide, gone at slide 2 or 3, which talks about what's my business use case is, right? So, and what I'm going to accomplish, what is my business outcomes are, right? We had this one more bar chart which showing using this chart, I mean, using this, generative AI, um, use case, I'm going to accomplish this percentage of the revenue, or this is my cost reduction, right? So it's having that tangible uh, goals will be super helpful to show that, okay, with this, am I going to generate new revenue, or I'm going to be increase the value of my offerings, or I'm looking into reducing the cost of my operations. So you got to pick how do you define the ROI of the when you embark on this generative AI journey. So that'll clearly makes the executives to know, okay, so it's just not the catchword or a catchy word or a buzzword that we want to, right? We have very well planned out approach to accomplish the business goals. Hope I did answer that question, Governor. I don't know, like this is, if you guys have, maybe you can unmute and ask that question in the chat, I mean, directly as well. Or, I can provide my, feel free to connect me on the LinkedIn, or shoot me a mail, so I'm happy to provide additional. Okay, recently McDonald's withdraw AI-based automatic order tracking system that it had developed with IBM, which is which AI model was used. Why did the setup fail? Can you please comment? Okay. Um, Let me say, I mean, I'm not completely privy to the entire thing. So they defined on accomplishing certain objectives in terms of like how do I make this a checkout is so seamless by populating all the menu items, right? Like, so where it becomes a conversational. So objective was that. I think even Wendy's have the same thing, but they're operational. But, looks like the McDonald's couldn't accomplish maybe the reducing the time what it is supposed to, and all the populating all the model. So I don't have the complete details. Maybe it's not on the technology part. It is more to do with the implementation part and the business outcomes. I can dig a little more deep and share that additional insights on it. Okay, looks like another. I have to leave. Do you mind making closure and thanking the audience? Okay, absolutely. Um, okay, if there is no question, yeah, Garnet, reach out to me. I'll type so you can look up, guys wanted, connect me on the LinkedIn. This is my LinkedIn. You can look up. You'll definitely find me there. So yeah, if there is no additional question, thanks, Priyanshu. Yeah, absolutely. Hope you walk away with good information on this. Yeah, if there is no additional question, thank you all. As I said, like, feel free to reach out to me, and yeah, any additional, either the technology or the business, and happy to answer your questions. Okay, thank you all. Take care. Bye-bye.